8.8. We're going to learn about how to factor polynomials completely. Let's first look at how to factor out a common binomial. So here we have x plus 4 as our common binomial. So we can factor that out and take 2x and minus 3 to form another binomial. So now we have two factors. The same goes for the next one, but first we need to turn this one around. To do so, we need to change the sign here, so that when we distribute negative 5 in, we still get negative 5y. And negative 5 times negative 2, we still get positive 10. And now we can factor out y minus 2. Now let's look at factor by grouping. Now I see that my variables are in decreasing order. I can group the first two terms and factor out x squared for the first binomial. And then for the next group, I can factor out 5. And we'll notice that we'll end up with a binomial of x plus 3 in which we can factor out. And this one, I'm going to use a strategy and move this next to x cubed. So now my variables are in decreasing order. I can group. Okay, now we see that we have a binomial, a common binomial of x minus 3, which we can factor out. So when a polynomial is factored completely, it will be written as a product of unfactorable polynomials. So they could be binomials, trinomials, etc., with integer coefficients. So here are the guidelines. To factor a polynomial completely, try these steps. First, factor out the greatest common factor. That's the very first thing you want to check. So with the first example here, I noticed that I can factor out 3x because that's the GCF between these two monomials. So then I would end up with 3x times the binomial x plus 2. And secondly, I will look for a difference of two squares, or a perfect square trinomial. So I see that this is x squared and this is 81. I can take the square root of 81. So this would be the difference of two squares. And the next example will be a perfect square trinomial. I can take the square root of x squared to get x, square root of positive 4 to get positive 2, and I notice that this is a positive sign next to the middle term. So this will be x plus 2 squared. And thirdly, we can also factor a trinomial of the form ax squared plus bx plus c into a product of binomial factors, in which we learned in an earlier lesson. So I can first find my magic pairs, and I see that when I cross 3 times negative 2, I get negative 6 here. 1 times 1, 1. 1 plus negative 6 gives me negative 5, which is equal to this coefficient of the second term. And now I can write my two factors. 3x plus 1 times x minus 2. So This is a product of binomial factors. And the next one, fourth, factor a polynomial with 4 terms by groups. So I'm going to rewrite this in decreasing order. So now I can group the first 2 and the last 2. I'm going to factor out x squared. And now I notice that I have a common binomial which I can factor out. And this will be considered factored completely. Okay, let's do more practice. Okay, and I look at this first example here, and I know I need to find the GCF. So the GCF between these 3 binomials will be 4x. And now I see that I can factor this trinomial into a product of 2 binomials. So negative positive makes negative negative, and I believe I can use 3 and 8, because negative 3 times negative 4 gives me positive 24, and negative 3 plus negative 8 gives me negative 11, so we're good. So this is factored completely. And the next one, I need to find the GCF between these 2 terms. That makes 3x, x squared minus 4. And I notice that this is a difference of 2 squares. So I can factor this further. And that will be complete. And now for the next one, I can also take out the GCF 2y. So I'll get y squared minus 6y plus 9 as my trinomial. And I notice that this is a perfect square. So I can do this. And for the next one, I can factor out the m. And I notice that this is not a perfect square trinomial, so I need to find the product of binomial factors. So, negative, negative, positive, negative. And I need to use the factors 2 and 4. So positive 2 times negative 4 gives me negative 8. Positive 2 plus negative 4 gives me negative 2. So we're good to go. This is factored completely. And for this next one here, I see that I have a common binomial. I'm going to factor that out. And then I see that this could be a little complicated, but we could just treat this like one variable. Okay, and you see the coefficient here, 8 and positive 15, so we need to find that magic cross. And I'm going to try 2 and 4 with a pair 3 and 5. Let's cross this. Now, we don't have to worry about the signs here because this is positive and this is also positive here. So 2 times 5 makes 10, and 4 times 3 makes 12. And when you add this together, you get 22, which is the coefficient here. So now we're ready to factor. So I'm going to take 2 times y plus 3 plus 3. That'd be one factor. And I'm going to take 4 times y plus 3 plus 5. That would be my other factor, so we could check. 2 times 4 makes 8, and we got 2 of these, so y plus 3 squared. And then 2 times 5 makes 10 times 1 plus 3. And then also for the inner, 12 times y plus 3. So that makes 22 times y plus 3. And then we have 3 times 5 making 15, so we're good. Now we could further simplify this. So this we could distribute 2 into the binomial y plus 3, 2y plus 6 plus 3 plus 9. And then distribute 4y here. 4 times 3 is 12. 12 plus 5, 17. And then this is factored completely. Let's try one more. And here it says try factoring by grouping. Okay, so you see that there are two like terms here, so just ignore that. Let's group this. I'm going to factor out 3x, the GCF between these two first two terms. So that makes 7x plus 5. I'm going to factor out 2, also makes 7x plus 5, and we end up with two common binomials, and which can factor out, and then we're done. Okay, here we have solve a polynomial equation. So we still need to factor the left-hand side of this equation, so I'm going to factor out the GCF w. W squared minus 8w plus 16. Now I notice that this is a perfect square trinomial, so I could do w times the binomial w minus 4 squared. And set that equal to 0, and then I can use the zero product property, and I know that w can be 0 or w can be 4. And the next one, I'm going to factor out x to get x squared minus 25. And I notice that x squared minus 25 can be further factored by a difference of two squares. And from this, I can see that x is 0. And x can also be negative 5. X can also be 5. The next one, I need to set this equal to 0. And now I can solve, and we can factor out 3x. And I notice that this is not a perfect square trinomial, so I need to find the product of binomial factors. So I can do, let's see, 4 and 2. X plus 4, 2. So 4 times 2 gives you 8. 4 plus 2 gives you 6. And then x here can be 0, negative 4, negative 2. Okay, for this next one here, I need to rewrite the equation so that it's equal to 0. And then I can use the zero product property to solve for x. Okay, so I move the 10 over, so I need to change the sign. Now x plus 3, I'm going to just treat that like a big variable, but it's a binomial, okay? So we could just look at negative 10 and find a pair of factors so that the product will equal to negative 10 and the sum would equal to positive 3. So we can continue. Let's just first write this down. And our signs, positive, negative, positive, negative. And then I know I can use 2 and 5, okay? So I would make 5 positive and 2 negative. So then when I take the products, it will equal to negative 10. When I take the sum, it will equal to positive 3. Now I can further simplify this, x plus 8, x plus 1. Now by the zero product property, x can equal to negative 8 or negative 1. For the next one, x, I also need to move negative 81x over to the left-hand side and set the entire polynomial equal to 0. And then I could factor out x to get x to the 4th power minus 81. Now I can further factor this as x squared plus 9 by the difference of squares. And there's another one here that we can't leave out. We also need to use a difference of squares, x squared plus 9, x plus 3, x minus 3 equal to 0. Now here, x could equal to 0. Here, x could equal to -3. X can also equal to 3. And we need to solve for this and see if we could really solve for it by using the zero product property. So we set that equal to 0 and you get x squared equal to -9, which is not true. So we just ignore this one. This is our answer. And here, this is a slightly more complicated one, but that's nothing to worry about. We could clear the denominator by multiplying by the LCM of x cubed, x squared, and x, which is x cubed, because we just take the larger power. So this makes 1 minus 6 times x equals -9x squared. And then I can rewrite this entire equation as 9x squared minus 6x plus 1 equal to 0. And I need to factor this. And I see I can use perfect square trinomial, because this is, I could square this to get 3x. I could square this to get +1. And since I have a negative sign here, I need to use the subtraction sign. Go to 0. So to solve this, x would equal to 1/3. Okay, now we have a special case. Is the following polynomial factorable? Now if we use 1/6, it's not going to work. If we use 6/1, it's still not going to work, because 6 minus 1 gives you +5. -6 plus 1 gives you -5. So we can't use 1 or 1/6. If we use 2/3, 2 plus 2 minus 3 gives you -1. Doesn't equal the coefficient of the middle term. And if we use 3/2, we get +1. So it doesn't work. It's unfactorable. So polynomials that are unfactorable over the integers is said to be prime. So if I give you something like this, you just write prime. Okay, word problems. A terrarium in the shape of a rectangular prism has a volume of 4,608 cubic inches. Its length is more than 10 inches, so we need to keep that in mind. The dimensions of the terrarium are shown. Find the length, width, and height of the terrarium. So I set up this equation here for you. I took the length, the width, and the height, which is w plus 4 on your notes. Okay? And I set it equal to 4,608. And now I'm going to switch this binomial around so that the variable will be in the front. So I need to put a negative sign out here. When I distribute the negative in, I will still get -w squared and +36w. Okay? And then now I can take this binomial and this binomial and expand it. And I could distribute a -w in. And I need to move this over so that this is equal to 0. And now what I can do is group this. I'm going to factor out -w squared to get w minus 32. And then here I'm going to factor out 144 to add w minus 32 as well. And then now I see that I have a common binomial. I'm going to factor that out. So I get w minus 32 with 144 minus w squared, which equals to 0. Now we have a couple answers for w. Now w can be equal to 32 or positive 12 or negative 12. Well, we can't have a negative length, so we can cross out the negative. Now we need to decide whether we have to use 32 or 12. And it says here that the length is more than 10 inches. So if we take the length here, 36 minus W, and we use 32, we get 4 inches, which is less than 10. So we can eliminate 32, and the width will obviously have to be 12 inches. So we could write that down now. And the length will be 36 minus 12, which is 24 inches. And then the height, which is W plus 4, we could take 12 plus 4 equals 16 inches. And here are our dimensions. And just a reminder, 24 inches is greater than 10. That's required by the word problem. Okay, poster tube in the shape of a cylinder has a height of 2 feet and a volume of half pi. Write an equation for the volume of the poster tube. Well, this would be the formula. I could further simplify this equation by substituting in for the given information. I could cancel out the pi, and I could divide 2 to both sides of the equation so that it would become 1/4 equal to r squared, or 0 equal to r squared minus 1/4. And part B says, or states, what is the radius of the poster tube? So we can solve for r by using the difference of squares, because I could take the square root of 1/4 to get 1/2. And r can equal to negative half or positive half, but we can have a negative length, so we ignore the negative. So your radius will be half feet. Okay, and this concludes the lesson.